Hi, so for today we're going to talk about the linearity and homogeneity of differential equation. This is basically classifying the differential equation, whether it is linear or non-linear, and homogeneous and non-homogeneous. So let's get started. So an nth order ODE or ordinary differential equation is linear if we can rewrite it as the following formula. So for the first one, we have a sub n of x, any constant as a function of x, and then multiplied by the nth derivative of dy all over dx raised to n. So nth derivative of y with respect to x. So again, if we recall our introduction, our dependent variable here would be the y, and our independent variable here is the x. Okay? The x plus a sub n minus 1 of x, still a function of x. This can be a constant, okay? And multiplied by d raised to n minus 1 y, okay? So the lower derivative, okay? So and so on and so forth until such then we have a sub 1 x here and the first order dy dx here until such then we have plus a sub o or a sub 0 of x, okay, multiplied by y equals some pure value in terms of f of x, or it can be a constant or it can be 0. Okay, but not the uh, dependent variable. It should not contain the dependent variable. In this case, in our equation, the dependent variable again is y. Okay? So here is the form. If f of x equals 0, then it is said to be homogeneous. If not, if this f of x actually contains what? Constant, that's non-homogeneous. Okay? So, we have two things to take note with regards to linear differential equations. So we have the dependent variable y in this case in our equation because the dependent and independent can be changed. It is not always y and x. It can be x and t, okay? Or z and t. So it depends. So this formula is only for x and y, okay? Dependent variable y and independent variable x. So it can be interchanged also, okay? Dx over dy. So in that case, x would be the dependent and y would be the independent. So the dependent variable y in this example and all its derivatives y prime, y double prime, etc., y raised to n, nth derivative are of the first degree, meaning uh, their power, the power of each term involving y should be equal to 1. Okay? If there are derivatives, okay, in this case, in our equation, that is not of degree 1, then that is already non-homogeneous. Okay? So that's the point number 1. So the coefficients a sub o, a sub 1, up to a sub n of y prime, y double prime, up to nth derivative of y depend at most on the independent variable x. Meaning, okay, the values of this function should be in terms of x or can be a constant since x is independent variable in our equation. Okay? So this should be x or any constant value. Okay? It can be 0. Okay? So in this case, if this is 0, we have no nth derivative something. Okay? So it can be 0. But it should not contain the what? The dependent variable y. So, meaning this a sub n x, this one should not contain any y except for this. Okay? Except for this one. The one that has no derivative. Okay? So, sorry. So, again, it should not contain y up to the term that has derivative. So, as you can see here, it is y. Okay? So, it does not have any derivatives. So, okay. So, and this y, again, should be what? Of the first degree. Okay? So, let's try to answer some of the given example. So, we have here 1 minus x of the second derivative. Okay? So, if we are going to rewrite this, so this would be 1 minus x. Okay? Second derivative of y with respect to x. Okay? And then we have plus 3. We have dy all over dx because it's only y prime equals x. Okay? So 1 minus x is actually in terms of purely in terms of x and a constant. So that is a check because okay, we don't want this value to depend on the dependent variable y. It should be the independent, which is in case x. So that is correct. So in this one, so we have the second derivative. Then we don't have this is the first derivative, of course. That's the first derivative, and we don't have this term. And that's okay because maybe the value of a sub 0 of x is 0. So that we don't have this. So plus 3. 3 is can be a function in terms of x. It's constant. Okay, so it's checked. Okay, so we don't have any y term here in our derivatives. Okay, and of course, that is equivalent or equal to x. That is purely in terms of function f of x. So that is again another check. So therefore, the answer to this is that this is linear, okay, differential equation. Okay? That is a linear differential equation. And since we have f of x not equal to 0 but some value of f of x, okay, so this is non-homogeneous differential equation. So again, this is linear in y, okay, the dependent variable. So what is our dependent variable here? Okay, let's write it as dv. The dependent variable here, so dependent variable dv would be equal to what? The y. Independent variable is what? Equal to x. And the degree, order, okay, just for us to be reminded, the order of this is first order, okay, and first degree or degree 1, okay? Because the degree of the highest order of the derivative is 1, okay? So it's linear. Okay? So I hope that is clear. For number 2, let's try. Okay? So number 2, y prime, usually this is dy over dx. So if we rewrite that, so we have dy all over dx plus sine of y equals 0. Dy all over dx, so we have a 1 here. It's okay. For our a sub 1 of x, we have 1. But as you can see here, class, sine of y is not what? It violates the note 1. Okay? So number 1 rule. So the power of each term involving y is 1. Okay? So actually, this is non-linear because of this transcendental function sine y. Okay? Sine of y. So, we are actually trying to eliminate or trying to avoid using this transcendental function with the dependent variable y. Okay? If this is the independent variable x, sine of x, okay, it's okay. But then it's the dependent variable. And in rule number 1, the dependent variable, okay, should be in first degree or should be linear, okay, in terms of graph. Since the graph of sine of y is not, uh, what do you call this? It's not linear, okay? So, this sine of y, this equation could be classified as nonlinear, okay? Differential equation. Okay? I hope that is clear because this is nonlinear. Sine itself is not linear. Sine of y. So, it's important that the dependent variable should be linear. Okay? If this is replaced by simple y, okay? Simple y. Okay. So, it's okay. Right? It's so, since this is nonlinear, it is nonsense to talk about if it is non-homogeneous or homogeneous because none of the uh, techniques that we're going to use here, okay, is suitable for what? Uh, Suitable for solving that differential equations. Okay? Equation. So it's nonlinear. So again, the dependent variable here is y. Independent variable is x. Okay? So we have the first order, first degree still for number 2. For number 3, okay, let's try to have number 3. So for number 3, we have, rewrite this, we have third derivative of y with respect to x plus 3 dy all over dx plus 2y equals x squared. Okay? So that would be our example. So third derivative with respect to x. So we still have a sub x as a function here as our uh, equation. So we have 1. So it's checked. Okay, we don't have second degree. Maybe the a as a function of x value is 0. So we have the first derivative, and this is the constant in terms of x. Okay, so 3, that's a value of a of x of dy over dx. So we don't see any dependent variable attached or multiplied to this 3, and the same as this. And finally, we reach the term that has no derivative. Okay, and we have y, and we have the a sub 0 of x or a sub 1 or any constant. So that's still checked. And of course, it is equal to what? It's equal to x squared. Okay, so it's not equal to 0, but still, this is purely in terms of what? Df of x, or purely in terms of the independent variable. So therefore, this is linear. Okay, and of course, this is non-homogeneous because it's equal to x squared, not to 0. Okay, and then, okay, it has what? Third order. Okay, it's a third order. And then degree of 1, first degree. Okay, the independent variable is x and the dependent variable is y. Okay, so number 4. Okay, still we have what? We have third derivative of y with respect to x. Okay, plus we have 4 first derivative dy dx y prime plus 2y equals e raised to y. So we don't have any problems with regards to the first term, second term, as they are all the same with this example. But the constant term equals e raised to y. So since this is not, this should be equal to a purely in terms of constant. It can be 0, it can be a constant 2, 1, negative 1, 10. Okay? So, and it could be what? In terms of x, because independent variable is in terms of x. But since none of those conditions are met, but rather this is equal to an expression equivalent to the dependent variable, then definitely this is non-linear. Okay? This is nonlinear because the constant term should be what? The right side of the equation should be purely in terms of the independent variable x, or it can be a constant. Okay, it can be 0, 1. But since this is in terms of y, then that definitely that is nonlinear. So number 5, we have x squared. Okay, x squared, second derivative of y with respect to x, plus we have x dy all over dx. And then we have plus 4y equals x cubed. So as you can see here, we have this term at most dependent on the independent variable x. So that is correct. Okay. And then we have again a term here dependent on the independent variable x. Okay. So still good. Okay. Then we have dy over dx here. And then still there is non-derivative. Okay. It should have a y that is raised to 1. Okay. So that is raised to 1. Its degree should be always 1. And then we have a constant 4 here. That is correct. And then it is equal to a purely in terms of x. Okay? So this is what? A linear differential equation. Still a non-homogeneous since that is not equal to 1. So second degree, second order, second order because the highest derivative is 2 and its power or degree is 1. Okay? So second order, first degree. Okay? Dependent variable is y, independent variable is x. Okay? So I hope you are learning in our lesson. Number 6. So we have number 6, we have 1 minus y. We have dy all over dx plus 2y equals e raised to x. So as you can see here, we don't have any problems with the f of x since this is purely in terms of the independent variable x, this one. Okay, we don't have any problem with this one. This one also, we don't have any problem because this is linear or has a first degree, y. And then we have an a sub x, a in terms of x, constant 2. Okay, but the problem is that in this term, we have y. Okay, in which our second note or condition is that the coefficients of this of the derivatives a sub 0, a sub 1, etc. should be dependent at most at the independent variable x. So since this contains a dependent variable y, okay, so it's a big no-no. So it should not contain any y in the derivatives, okay, in terms of its derivatives. So again, the failing part of this is the first term. So this is classified as non-linear differential equation. It is non-linear. Okay? So, let's try number 7. So for number 7, it's obvious the fourth derivative of y with respect to x. Okay? So we have there is no correct or there is no nothing wrong with this term. Okay? So it has a coefficient of 1, constant of in terms of x as 1. But the problem is this. Okay? So the problem is this is raised to 2 wherein all of the y, okay, independent variable y and all of its derivative are of the first degree. That is, the power of each term involving y should equal 1. Okay? So, but the power of y here is not equal to 1. So, it's non-linear. Okay? So, we have non-linear differential equations. Okay? So, and for number 8, let's try for number 8. Okay? So obviously, if we try to free this term with its square root, we can square this both sides. Okay? So we have second derivative of y with respect to x squared. Okay? And then we have 1 plus what? dy all over dx squared. Okay? So obviously, okay, this is a non-linear because again in our condition, okay, all of its derivative of the dependent variable y, okay, should be raised to a power of first degree, power of 1. So since again we have raised to 2 here, okay, we have raised to 2 here, so definitely it's very obvious that this is non-linear differential equation. Okay? It's a non-linear differential equation. Okay? So how about this? Okay? How about this? For number 9, let's try. Let's try to have another variable. So, second derivative of x with respect to t, okay, minus t dx all over dt, okay, minus 5tx, okay, equals negative 25. So what do you think? So again, we can still use the formula above, but at this time, our dependent variable is x. Okay, that is our dependent variable. And our independent variable is now t. Okay, so we can imagine that this is x and this is t. Okay, and of course, our f of x would be replaced by purely in terms of t or a constant or 0. Okay, so again, the same rule applies. So the dependent variable uh, x, okay, we will be replacing this, and all its derivative are of the first degree. That is the power of each term involving x, okay, is 1. So the coefficients of this depend at most on the independent variable. In this case, it's t. The independent variable is t. So is this linear or not? Okay, let's try. So we have a 1 here dependent on the independent variable t. So it should be a of t. Okay, constant in terms of t. That is still correct. Okay, second derivative. Minus, we have t dx all over dt. This t is the a of t. Okay, it should be multiplied to the independent variable t. So it's okay. Okay, we don't have any x here because probably if we have minus xt here or minus tx, then definitely that is nonlinear, automatic. It should not contain this constant or this term, okay, should be most dependent on the independent variable t. Okay, so and then minus 5tx. So here is our term x, here is our dependent variable x. A while ago, we have y, of course. So it is present and its degree is 1. And we have a constant in terms of t, 5t. Okay? And then we have, on the right side of the equation, we have purely in terms of t or constant. And it's not equal to 0. So technically, this is classified as a linear differential equation. And since the f of t, okay, or the side here is not equal to 0, then that is non-homogeneous. DE. Okay? Non-homogeneous differential equation. Okay. So again, dependent variable is x, independent variable is t. And then, of course, we have the degree and order. The order is uh, second order. Okay? Second order because of this. And the degree is first degree or degree of 1. Okay? Okay. So for your problem, okay, here's your problem. Identify if it is linear or non-linear and identify the variable, uh, dependent variable, independent variable. So I will leave you with this question. Okay. So that's it. Okay. So what's is it linear, homogeneous, non-homogeneous? Okay. Is it non-linear? Okay. If it's non-linear, so we don't care about if it is homogeneous or non-homogeneous. So just classify the degree and the order. So if it's linear, then homogeneous or non-homogeneous. So yeah, that's it. So I hope you learned something for today's video about the linearity and homogeneity of differential equations. Again, if you are new to my channel, this is Engineer Abat. Thank you so much for listening. Please don't forget to subscribe to my channel. Thank you so much and God bless.